We finished the chapter off on functions with the exponentials, etc. Now, what we're going to do now is we're going to start looking at, now that we can draw them, what if we get given graphs that intersect, we get lines going through each other, where we have to find lengths, we have to do domains, ranges, and we generally have to solve problems pretty much similar to an analytical geometry kind of condition. So let's just have a look and see before we move on. Let's just revise a few little notes from revision, right? From revision, from last year, okay? Remember, I just made a few little sketches here, and I said to myself, okay, let's just revise, and we've got a graph over here, and we know it's a straight line graph, and we know y is equal to mx plus c, and we know that if we have coordinate a there, it's got coordinates xa and ya, and down here somewhere are coordinates b with xb and yb, okay? And we say, okay, remember, let us say, for example, let's give that a coordinate, shall we? Let's call it minus 2 and 4. Right? So what do we know about that height? It's 4 units. What do we know about that length there? It's 2 units, okay? Because that's minus 2 and that is 4. So, cool. Now, if we have a look at b, let's give b some thingies. It's 6 and minus 1. 6 and minus 1. Well, what does that mean? It means that we are along here. If I measure, I'm going to have 6 units, and down here I'm going to have 1 unit, aren't I? Okay. So finally, I can come along and I can say, okie dokie, how far is it from there to there? And I know that it's going to be 5 units, the length vertical. So let's just go back and say, all right, length of AC, okay, call that C. Length of AC is going to be delta y's, isn't it? In other words, when we're looking at lengths in the vertical, we're looking at the difference in the y coordinates. Ditto, when we're looking at the length in the C to B, BC or CB, okay, we're looking at delta x. We're looking at the length of the line that goes from the coordinate to the coordinate. Okay, so, and remember here, we've got to use the sign when we're doing this, okay? Right, and or the last thing, of course, is this. You cannot have a negative length. Right? You cannot have a negative length. Okay? You can't measure yourself backwards, basically. But let's just have a look. And also, always our measurements. And remember, if they don't tell you, then you use units. Units of length, units squared, units cubed if it's a volume. Okay? We're always going to do that. Okay. Now, let's just take a simple parabola, right? I've got over here, I just want to draw my little parabola, just move them down slightly, ever so slightly. And we've got a point, let's just say, over here. I'm going to draw my parabola going up there, through there, turning, and then coming down over here. All right? And remember that this was the root there, and another root there, and that was the y-intercept. The y-intercept, right? And that's generally c on the function, isn't it? Now, let's say we have a graph. I'm going to draw that in a different color. Let's do green. Okay. The graph goes there, and I call that point A and point B. Now, let's call this f of x, and let's call the other one g of x. Okay. Now, let's just talk about this. How do I find a and b? Okay. Let me just slide it down. To find the coords A and B, those points of intersection, we put f of x equal to g of x, don't we? Right? So if we want to find where any two graphs intersect, we put them equal to each other. So we put them into function form, f of x and g of x, and we then put them equal to each other. Essentially, we are equating the y value. We're saying y equals this, y equals that, therefore we put them equal to each other. Okay. So therefore we put equal and we solve for x. Excuse me. Then back sub for the y value. Back substitute for the y value. Okay, I know my writing is not great. Okay, so we back sub. That's pretty standard. That's everything we've done up till now. Well, what if we want the length CD? Now, let me put in over here. All right. Let's just put in the a few other little points, shall we? Red. Let's say we've got point over here. It doesn't matter where it is. C to D. Or point E to F. Okay. Just go blue. Or point E to F. Okay. Now, how do we find the lengths? Well, it's vertical. Therefore, we must have a delta y. So we need to subtract the y coordinates from each other, don't we? Okay. There and there. That will give us that length, the vertical length. So what is the y coordinate on top and the y coordinate at the bottom? Now, this is where it's important. When you're looking for these, okay, the length, you want to take, all right, you say it's a vertical line, therefore it's delta y. So we want a vertical, sorry, let me just put it back to black. Vertical height, want a vertical height, therefore it's delta y. We're working with the y coordinates. Therefore, to find that, we need to say it's going to be function, the length is going to be, now which one is on top? It's the top y minus the bottom y, isn't it? So therefore the length is going to be equal to, in this case, g of x minus f of x. This is the top minus the bottom. All right. Let's just go and recap it. Can you see there? It's the top minus the bottom. Top minus the bottom over here like that. Okay. So when we're looking at the length of a vertical line, we need to see which function is on top of the other function. That's important. Okay. And then we're going to say it's there. Well, you could say, okay, well, does that apply to everything? Well, yes, it does. Okay, what we're going to do now is we're going to look at two parabolas intersecting. Okay, a very favorite question that's asked. Okay, and I've got a parabola on top doing this, let's say. And just for thingy, let's put a parabola down over here. All right, like that, and please remember, it doesn't matter, these cut each other, A over there, rather A and B. I've said A and B is this height here, AB, then I've got another one over here, C and D, and over here I've got CD, E and F, let's say. What are points E and F? They are intersection points. How do we find them? I'm going to now put f of x on top. The green one is going to be f of x. And the bottom one is going to be g of x. We put f of x equal to g of x to get E and F, right? The points of intersection. Okay, we're going to do an example of this in a few moments. So that's what we do. So therefore now we can say, therefore the length of AB is going to be equal to y top minus y bottom. The y coordinate on top is the g of x at this point minus the f of x. All right. So you can see that if you look at that shape, okay, let us consider what can AB do as a line. Well, AB can move from there, there, and there, can't it? AB can move. So in between that shape there, right, that you've got, you can have 0, it gets bigger, and then it gets smaller again, back to 0. Just have a look at the line. If you take your pencil and put it at E and slide it across vertically, or horizontally, but keep your pencil vertical, you will find that you'll see that the line length increases and then decreases again, which means that the length of AB, all right, we could potentially find a place where it's the maximum. We are going to be doing that, okay? Right. Okay, then we say, don't forget, let's have a look at the other point. What about CD, right? CD is on the right-hand side, but we could also have a line over here, C prime, D prime, couldn't we? Right? So bear in mind, how would we find the length CD? We would say f of x minus g of x, wouldn't we? Length CD is going to be f of x minus g of x. Because this is my top function, this is my bottom function now. So I'm going to put whichever one is on top, I will put it on top and subtract the one that's underneath from it. Okay? That will then give me a function you're going to see in a sec. All right. So let us do it. Let's look at an example. I think that's the easiest way to do this. As an example. Okay, say we've got f of x equal to x squared plus 2x minus 6. And we've got g of x equal to minus 2x squared plus x and plus 8. Okay, those are our two parabolas. We know that one is upside down. All right, now we want the length of AB, let's say. All right, so in other words, we want the length AB. So if we drew this, this is my bottom one, that's my top one. So this is minus 2x squared plus x plus 8. My top one is x squared plus 2x minus 6. And I want the line AB, which is somewhere in the middle here. All right? So the first thing I say, it's going to be the top one minus the bottom one, don't I? Because it's in that in-between section. So I say, right, in that case, there we go. AB, LAB is going to be g of x minus f of x, right? Because g of x is on top, isn't it? So it's going to be top minus bottom function. Top function for that one is, and remember, minus 2x squared plus x plus 8. Why am I using brackets? Because if I don't, I'm probably going to make a mistake. Okay, in fact, not probably, the chances are very, very good we're going to make a mistake. Then we expand the bracket and we get g of x minus f of x, and I'm going to put the top one, okay, which is that. So I'm going to get, minus 2x squared plus x plus 8 minus x squared minus 2x plus 6, and I end up with minus 3x squared, okay, minus 3x squared, let me just see, that's that one and that one, minus 2x plus an x is minus x plus 6 plus 14, okay, I'm going to get that, okay. So now that is the function, this is my length function, isn't it? So now I can put in any value of x, subs a value of x, to get the length. Okay. I could, of course, have substituted it in over here, couldn't I? I could have substituted a value of x there, okay, this value, and found y of a, substituted here, found y of b, subtracted the two to get the net length delta y. Like that. Right? We could have done that if we wished, but we rather wanted the length y because we're going to be looking at maximizing it. All right? Now, how can you be asked this? Two ways of asking. Asking two ways. A, find length given the function, given the f of x and g of x. Okay, in other words, the two graphs. All right, basically what you're going to do, you're going to subtract the top from the bottom. Length is going to be equal to top function minus bottom function. Whoops. Okay, minus bottom function. Or B. B, we're going to be what? B is we are, let's put over here, B, we are given a length and asked to find the position. Let me put it that way. The position, which actually means they want the x value where that length occurs, right? And occurs like that, right? So in other words, if you look at that shape, they want to know at what value of x is it equal to that length. Therefore, we have got L, the function, equals a number given is equal to, in the previous case, ax squared plus bx plus c, or whatever that is. This is what you get when you subtract f of x minus g of x, the top minus the bottom. So in other words, instead of solving for the length given an x, you do the opposite. You're given a length, you solve for x. It's a quadratic, okay? We are going to do one or two of these functions. Now, I've got here in this section, okay, example. Let's do an example. It's always the best to do an example. That's not a very happy example writing, is it? The problem is writing on this thing, it's very slippery, so you tend to sort of write too fast. Given f of x, and they've said here f of x, okay, is equal to minus x squared plus 4x plus 12, okay, and g of x equal to minus a half x plus 3. Right, they've given us that, okay, and they will give us a diagram that goes with it, okay. I'm going to do my darndest to draw this as best I can, and we're going to have something that looks like this, and I'm going to put my over here, I've got a line going through there, I've got a line going through there, so I'm just going to put a line like, whoops, like that. You know what it's going to have to do, okay, like that, and then I've got a parabola going through the same point and coming back over there, okay. So I've got a parabola coming up here, and it turns, okay, there, all right, like so. Let's just try and make it as neat as possible, like that. And they've given us a turn. Right, they've got that there. All right. Calculate the coordinates of A, B, C, and D. So let's have a look. They've put in here A, B, C, and D. First off, right? Well, how do you calculate the coordinates of A? Well, first of all, just make sure you label this one, that this is f of x, and this is g of x, okay? Just label them. A and B, you put it equal to 0 and find the roots, and you get 6 and 0, and A, you get -2 and 0, okay? Then as you go through these things, put it on graph, okay? Don't leave it lying in your working. It's of no value there. That's where you get the marks. Where you generate it is in the engine up top. Put them in there. That's where you're going to use them. When you're going around looking to see what have you got, you want to see everything at a glance to see what you've got, don't you? Okay. All right. Put them on the graph. Line PQ is as shown. Okay, so now they say, okay, C is 0 and 3. It's a simple straight line. Point D is 0 and 12. 0 and 12. And then I always like to put the turning point in, and it is 2 and 1. Okay? 2 and 1. Okay. Now, the next thing they say to us, line PQ is drawn as shown. All right? Line PQ is drawn as shown. Right? And line PQ is going to be on this side, and it's at -3. Okay? It's at -3, so let's have a look here. That's -2, so once again, this is at -3 and 0. That is line P and Q. And they say calculate the length. Now, you know that the length is going to be y1 and y2, right? So what do? Calculate the vertical length. I need to put the length as the following. Length equals the top minus the bottom. So let's build up a function for that. The top function, okay, and it's vertical, so we say the top is going to be, in this case, g of x minus f of x, correct? The one that's on top is g of x. So therefore we take g of x minus a half x plus 3 minus f of x in brackets minus x squared plus 4x plus 12. Okay, and we subtract that lot, and we end up with x squared minus 4.5x and minus 9. Okay, that is my length function, is it not? Okay, that's the length function, right? Now I want to know the length at x equals -3. That's what they told me. So what do? Yep. L is equal to -3 squared minus 4.5 times -3 minus 9. And the length I end up with 13.5. Okay. Well, what else could I have done? I could have done it this way, couldn't I? I could have substituted in. I could have said y1 is going to equal to -1/2 times -3 plus 3. I've substituted in and I get 4.5. And that's y1, and y2 over here is the parabola -3 squared plus 4 times -3 plus 12. All I'm doing is I'm substituting -3 into the individuals. So I'm working out this now. Okay, I'm working out those two by substituting x equals -3 and finding that y, and then that y over there. Okay, I'm just doing that to just corroborate what I've done. And then I get over here that this is going to be equal to -9, and therefore delta y is going to be y1 minus y2, which is going to be equal to 13.5. And Kevin, you just forgot out something, units, and over here I have put in units already. So you can see the length over there is quite simple to work out. You take the top one, you subtract, use brackets because you're using a minus sign, so it's going to change the signs of your quadratic or of your straight line. Okay. Moving along, they then say, calculate the length of line RS drawn horizontally through the point of intersection in f of x and g of x. Line RS drawn horizontally, all right? Horizontally, all right? We'll get there. Horizontally through the points. So that's line R and S, isn't it? There. So what do we need? We need the coordinates of R and S. Always look on your diagram. Go back to basics. If you haven't got the coordinates, work them out. Okay. So how do I work out the coordinates? They are points of intersection. Therefore, put them equal. And if I do that, I put f of x equal to g of x, right? This is question part 3. All right, where we say, right, then minus x squared plus 4x plus 12 must be equal to minus a half x plus 3. Now, what do? Okay. We basically, this is a quadratic, so we bring the half x to the other side and we end up with an equation like this. Minus x squared plus 4.5x plus 9 equals 0. Then you change the sign to x squared minus 4.5x minus 9 equals 0. Okay. Then you put into your calculator or work out, you get x1 equals minus 3 over 2, and you get x2 equals 6. Check. It agrees, because we know from the drawing that one of the points of intersection is B. So it must intersect at 6 and 0. So there we've got that. So now we've solved for that. Okay, now I say I've got x there. Can I calculate y? Of course I can. I then say, calculate y. How? Substitute x1 equal to minus 3 over 2. Into which one? Into any one. I chose the easiest one. Minus a half x plus 3. So it's going to be minus a half times minus 3 over 2 plus 3 is equal to 15 over 4. Now I can go back to my graph and I can put in the coordinates. I say, okay, I've got you. Let me just put you now in maybe red. And I say my coordinates there are going to be minus 3 over 2, 15 over 4. Like so. And the next side, right? Now, how do I find the next one? Well, how do I find the coordinates of that? Well, I know the y. Sorry. I know that it's 15 over 4. Because it's horizontal, the y coordinates are the same. Same height, right? Because it's horizontal. Therefore, I can plug it in, and I can plug it into this one here and work out what my x coordinate is there. And we put 15 into f of x, and we end up with x1 equal to 5.5. Let me just do this, shall we? I'm going to put 15 over 4 into there. Okay. We are looking for, just put it down, finding the x coord of x coordinate of point S. Finding the x coordinate of point X, put 15 over 4 as y is equal to minus x squared plus 4x plus 12, and rearrange, take it to the other side. We end up with this minus x squared plus 4x plus 8.25 equals 0. Put it into your calculator and you say x1 is equal to 5.5 or x2 is equal to minus 1.5, which checks because that is point R, isn't it? It's the x-coordinate of point R, minus 3 over 2. Therefore, you can say now the length is equal to minus 3 over 2 minus 5.5, whichever way you want to put it. The total length is going to be 7 units. All right? And remember, if you've got minus minus, you just switch it round to the positive. Okay? 7 units is the length of that line. How else could we have done it? We could have used the turning point. You could have said, let's just go back to our graph here. Okay? You could have said, hold on, here we go. Let's just go here and put in, let's just use green. I could have said from here to there, right? I know that that is at point 2, so that distance, oh, sorry, I've made it too long, my apologies. Okay, to point R, to there, right? That distance along as an x is from there to there, is 3.5 and 3.5, correct? 3.5 is that's ugly, Kevin, is 3.5, 2 plus 1.5. Therefore, that must also be 3.5, which means the length must be 7 units. Done. Okay, that's the quicker way. Do you want me to go through that again? Working from the turning point, okay, it is symmetrical, isn't it? So point S is as far away from the turning point as point, it's that way, isn't it? This is exactly the same length. So therefore, I could have gone to the turning point and said the distance from R to that point there, R to there, is 3.5. Therefore, the distance from there to there must be 3.5. Therefore, the total distance is going to be equal to 7 units. Okay. The next part of this question is they have said to us, find the x-coordinate that yields a line of 14. Okay. Find the x value where the line is 14, length equals 14 units, and it lies between R and B. All right, let's have a look. What are they asking us? Pretty much we know that it's between R and B. So they want a length of a line somewhere inside here. Okay, so it's going to go at R at 0 up and then down to B at 0 again. So there's a vertical line. The top function is going to be f of x underneath g of x. So therefore, straight away I can say it's a length vertically. I can thus say, when I got my black pen there, I can say the length is going to be equal to top minus bottom, and the top is f of x minus g of x. Let's write down what we've got. Minus x squared plus 4x plus 12. That's our f of x minus brackets half x plus 3 is minus x squared plus 4x plus 12 plus a half x minus 3, which gives us an equation of, and this must be equal to 14. 14, right? 14, because given length, right? They've told us that height there is equal to that, and we're basically going to have that's going to come back to something like this. Okay, I'm just going to simplify it a bit further because we're going to put all that together. We're going to end up with minus x squared plus 4.5x minus 5 equals 0. Whoops, sorry. Then you're going to do what with it? Then we are going to do this. Okay. Sorry about the ups and downs there. We're going to put it equal to 0 and solve for x. We get x1 equals 5 over 2 and x2 equals 2. Therefore, we have two solutions. So at x equal to 2 and 5 over 2, that length will be equal to 14. Okay? Simple as that. Right. In the next piece, we're going to carry on. We're going to do another one of those as an example. I'm sorry, I've gone way over. Thanks for watching. Cheers. And we'll do another one in the next session. Also to Parabolas Intersecting. Cheers. Bye.